Okay, our primary goal today is to finish up your work with simplifying these rational expressions. So I picked out about 4 problems that are very similar to what you're going to work on in just a few minutes. And the instructions, just like yours, will be, say, simplify each expression and then state the excluded values. So if you recall, our goal with simplifying is to factor. If I look at number 1 here, I need to look at the numerator and the denominator and decide if there's any factoring that can happen. And, on top, it's not a trinomial with x squared, x, and a number. But I do think that there's a GCF that comes out. I think that I can factor 6 out of both terms on top. And if I do, I'd be left with x plus 2, because 6 times x plus 2 is the same as 6x plus 12. The bottom doesn't have a trinomial to factor, and in fact, I don't even see a GCF that's not 1. So I'll just leave the bottom alone as x plus 2, but I hope you can see what's going to happen. The whole bottom is a factor that will divide out just like the numerator will. So believe it or not, this expression simplifies to just 6. Just 6. But now I still need to do the state the excluded values part. I need to look at the denominator and decide, what value or values for x would make the denominator 0. That's bad news. So if I think about setting the denominator equal to 0, I get an equation that's really easy to solve. If x plus 2 is 0, the solution to that equation is x equals 2. And remember that that was telling me a value that I don't want. I want to know, I have to avoid the situation where the value for x makes the denominator 0. So what I'm going to say is that x cannot equal 2. If it were to equal 2, we would get 0 in the denominator, and that's bad. So here's my simplified answer. Here's my set of excluded values. So there's my answer. Here's my excluded values. If I look at number 2, the top, the numerator, is just one term. So there's really nothing to factor. I've got 28n. The denominator isn't a trinomial with n squared n and a number, so I can't do sum and product factoring. But I could probably pull out a greatest common factor. I think that 8 goes evenly into both terms, and I think 1n, the first power of n, goes evenly into both. I think 8n is my GCF. And to write what's left, I would think of dividing the original denominator by my greatest common factor. So 8n squared divided by 8n is just n. And 24n divided by 8n is 3. And actually, even though they don't completely divide out, I think I can do some simplifying here. I think my n's will divide out. And I think that 28 over 8, I think there's a number that goes evenly into both of those. I think 4 goes evenly into both of those numbers. So if I divide 4 out, I'm left with 7 on top and 2 on bottom. So my simplified expression would be 7 divided by 2 times n plus 3. I've divided out everything that can divide out, and I'm left with just this scenario now. Now when it comes to trying to decide what my excluded values are, I need to look at my original factored denominator. I can't look here because I might be excluding some things. So what I'm going to do is I'm going to set each of those factors equal to 0 here. So either 8n equals 0, or, and I'm out of room, n plus 3 equals 0. And I think that each of these equations is easy to solve for n. This one I could just divide both sides by 8, and I get n is 0. You know, 0 divided by 8 is still 0. For this equation, I could solve for n by subtracting 3 from each side. So what I'm telling you is that these two values for n are no good. So when I exclude my values, I'll say that n can't be 0 and n can't be negative 3. Here's my simplified expression. Here's my set of excluded values. Okay, looking at number 3 here, I've got n squared plus 5n plus 4 divided by n squared minus 4n minus 5. And I'm going to factor the top. I've noticed that the top here is n squared, something n and a number. I could factor that with sum and product factoring, hopefully. The first term of each binomial would have to be n to give me n squared. But I need two numbers whose sum is 5 and whose product is 4. And you know, I think that's positive 4 and positive 1. And you know, the bottom is a trinomial with n squared, something n, and a number. So I could factor that using sum and product as well. Here I need two numbers whose sum is negative 4 and whose product is negative 5. And I think those numbers would be negative 5 and positive 1. Does that work? If they add up to negative 4, yeah, and their product is negative 5, yep, that's it. Those are the numbers, all right. So I factored both the numerator and the denominator, and I noticed that I've got a factor n plus 1 that divides out both places. These don't divide out, there's no matches here. So I'll simply say that this simplifies to n plus 4 divided by n minus 5. And when it comes to my excluded values, and you might be getting to where you can do this part without writing out a lot of work, but I'm going to go ahead and write it. I guess I'll actually go over here to get out of the way of my answer. I want to say that either n minus 5 being 0 would be bad, or n plus 1 being 0 would be bad. And those are actually both easy to solve for n. This equation's solution is n equals 5. This equation's solution is n equals negative 1. So when I write my excluded values, those are the values that I need to say n can't be. N can't be 5, and n can't be negative 1. And let's do one more for an example. Look at number 4 here. I've got 6p minus 18 divided by p squared plus 5p minus 24. I'm going to factor the top, but it's not sum and product factoring because I don't have p squared, p and a number. I can pull out a common factor though. 6 goes evenly into both terms. So 6 times p minus 3 would be 6p minus 18. The denominator is p squared, something p and a number. I could probably factor that using sum and product. Let's try it. I need two numbers whose sum is 5 and whose product is negative 24. I think positive 8 and negative 3 works here. Sum of 5, product of negative 24, yeah. And here again, I fortunately have a factor that simplifies. My p minus 3's will divide out. So I can write my expression using what's left over as just 6 divided by p plus 8. And when it comes down to which values can't I have, well, if p plus 8 were to equal 0, that would be bad news, because I'd get 0 on bottom. And it's also true if p minus 3 were to be 0. And my solution set for these two equations, p equals negative 8, would be a bad choice, and so would p equals 3. So for my excluded values, I'll say that p can't be negative 8, and that p can't be 3. It's time for you to try this now. You've got a set on my website to try. Make sure you save time to review this topic and also a couple of previous ones for a mastery assessment later today.